We are here in the Sioux Falls Downtown Public Library. I grew up a few blocks from here on the north end of Sioux Falls. I'm a writer, and my most recent book is Caesar's Last Breath. The story behind the title, Caesar's Last Breath, it's sort of a classic challenge problem for chemistry and physics students. A professor asked them, what are the odds that you're breathing a molecule right now that Caesar actually breathed when he was assassinated in Rome in 44 BC? And the trick of it is, initially you think there's no way that we're breathing any of those molecules in. I mean, a breath is about the most ephemeral thing you could ever imagine, and he died so long ago that it just seems impossible. So the answer has to be zero. But then if you look at it a little more, most of the molecules that we're breathing out are nitrogen molecules, which are very hardy molecules. They stick around for a very long time in the atmosphere. And the other thing is that the breath would have been spread around the world so uniformly, and there are so many molecules in each individual breath that you start to think, well, maybe it might be possible. So there's really kind of this tug of war between, a really tiny number, which is how big a breath is compared to the atmosphere, and a really big number, which is how many molecules are in each breath. Turns out if you do the math, they kind of cancel exactly, and it ends up that there's probably about one molecule of Caesar's last breath every single time you take a breath. So it's really this direct material connection to one of the most famous people who ever lived. So that's where the title comes from. The story of Caesar's last breath matters is because it's about the only connection that we have to someone like Julius Caesar. He died in 44 BC, so his body is long gone. Most of the buildings around there are gone. His clothes are gone. Even the iron daggers that stabbed him have long ago rusted into dust. They are gone. About the only thing we have left of Julius Caesar that was ever connected with him materially is his breath, were those little bits of air that came out of his lungs and started to spread their way around the world. And it's not just Julius Caesar. You can connect it with anyone that you are interested in history. Relatives, people you like, people you don't like. The air is one of the very few things that connects all human beings throughout history. Even the people that we now don't have anything remaining of their lives, we know very little about them. We do know as a fact that bits of their air are still around, that we're still breathing them, and we still have that material connection to them. And that encapsulates the title of the book, The Caesar's Last Breath, because what I'm trying to do is show people a different side of the atmosphere. The air is sort of this invisible thing, and we all know it's kind of important, but we hardly pay attention to it. We don't think about it much. And I wanted to show people that there is kind of this hidden, fascinating side to the air as well. And if you look at it, you can really connect it with a lot about our biology, about our history, our civilization. It's really one of the most important things around us, even if we take it for granted sometimes. So with each of the stories I'm telling, what I really want to do is get people engaged with it, to think about it, not as something kind of abstract and locked away in the lab, but something that really touches your life in a direct way. And I think the way to do that is with stories, because the human brain works best when it gets information in a story form. So if there are heroes and villains, if there's conflict and drama, and all these great things we want in a story, we're very good at remembering that. We pick up on that, and we do that a lot better than we do sort of abstract scientific facts. So what I try to do is I try to spin each of these tales as a story. So some of my favorite stories in the book, a few come to mind. There was one about the ozone layer in the atmosphere, and about how kind of this unusual quirk of the ozone layer, and some scientists studying it, is related in kind of an unusual way to the Roswell supposed alien invasion in New Mexico in the 1940s. So something you'd never think to connect, the ozone in the air with the Roswell alien invasions, but there's a very direct link to those things. So with the Roswell story, we know about the ozone layer, we know it should be important, but you wouldn't think to connect it to some sort of like alien invasion. So it goes through the people who were doing this work, what they learned about the ozone layer, how they tried to take advantage of it. And what it basically was doing was they thought that there was a quirk of the ozone layer that would allow us to spy on the Soviet Union and their nuclear weapons testing. Because it turns out that because of the different temperature layers in the air, basically it channels sound. So there's what's called the sound channel up there, where it takes sound, sort of magnifies it. And we don't know about it down here, obviously, because we're much lower than the ozone layer. But when you start to get up higher, you can hear sounds magnified. And I thought, wouldn't it be great if we could spy on the Soviets by floating these giant balloons with microphones on them up there? We could hear if they're testing nuclear weapons. And so they were suspending these kind of gigantic gangly balloons with all this equipment up there high up in the atmosphere. Eventually, some of them started to come down, they started to crash, and some of the equipment that they started finding around the Roswell area was things that they were sending up to try to spy on the Soviets. So it connects the atmosphere with this big political thing with the Cold War, and then the US government trying to cover up what was going on there. So this big connection to something like the Cold War is just something you wouldn't think about with the atmosphere. So there's one story, I hesitate to bring it up a little bit. It was about a performance artist in Paris in the late 1800s in the Moulin Rouge. And his talent, to put it frankly, was he was a fartiste, they called him. He was basically very good about inhaling air through his rectum. He would release it back out, and he would do impressions with that. He could do roosters, he could do dogs, he could do human beings, he could sing the French national anthem through his backside. He could blow out candles, play instruments. This man was very, very talented. And this story did sort of make me choke on a glass of water the first time I read it. I couldn't believe this person existed in the first place. But I thought about it a little more, and I thought, you know what? I've always been kind of curious about what's going on there, and like most people, I think, but I didn't know much about it. And so I said, you know what? I'm going to try to see if I can make this a little bit more scientific, learn a little bit more about it, because we're all curious about it. And it turned out to be a really fascinating chapter. I feel like I really did learn a lot, in addition to being able to laugh a lot about this guy. So, a few things I learned. Most people think that methane is the part of gas that smells. That is not true. Methane has no odor whatsoever. It's a lot of different other gases that are smelling. Most of it is produced in-house, so to speak, by bacteria. What they're doing is they're taking the things you eat, they're breaking them down, making some of these smelly chemicals. Most of these chemicals have sulfur involved with them. If you've ever been near a volcano or an eruption or, in some geological hotspot, you might remember that there was a smell. It's usually a sulfur-related smell. So that's another question people always want to know is, what are the odds that I'm still breathing the farts that someone exhaled? And the answer is it depends a little bit. If someone's in the vicinity, then I have to break it to you. You might be breathing in a little bit of those things. However, those molecules are usually a little bit more reactive, a little bit more volatile, so they're going to break down pretty quickly over time, whereas, say, the air that you're exhaling, which is mostly nitrogen molecules, those are going to stay around for a much, much longer time. So the odds of you breathing in Caesar's last breath and not Caesar's last fart are much, much higher. I guess the inspiration overall was that I knew there would be a lot of great stories about the atmosphere. But it's also a very topical topic in that it's something people are worried about, they're thinking about in some ways with climate change, global warming. So I really like that combination of it being a fun topic, but an important one as well. So the current state of our atmosphere, there are a couple different things going on. It's not all doom and gloom. One thing we have been good about is cutting down on chlorofluorocarbons, which we're eating a hole in the ozone layer. Ozone layer hasn't recovered yet, but it has started to build up a little bit. So that is a success story. We have done some good things. Unfortunately, there have been other problems, as I'm sure most people know, with levels of carbon dioxide and other greenhouse gases rising in the atmosphere. And unfortunately, it's getting to the point now where simply cutting back on those, it might not be able to sort of hit pause on climate change, where we might need to look at more active solutions, where we're really trying to pull things out of the air and put them in some sort of solid or liquid form so they're not trapping heat from the atmosphere anymore. I hope people walk away from the book with a couple of things. One, I want people to know, to pay attention to the atmosphere, to look at it in a little different way, to think about it, to think, the air really is a cool, interesting thing. Scientists sometimes say that the atmosphere is the most complicated system that we know of besides a human brain. And it really is an intricate, amazing system if you get a little bit more information, look at the details. But even broader than that, I think something I try to do with all my books is to make people think that science can be fun. You can be touched by science. You can cry a little bit. You can laugh with science. It really is a human activity, and I want people to know that all of the things we enjoy about being human are in science as well.